Hi guys, welcome to the last class, hopefully for this C Sharp course. And today's day number 11 actually. And we were supposed to finish it off in 10 days, but again, my calculation went just a little bit off. So to be extending to day number 11, and we're going to talk about the basics of C Sharp classes, OOPS, and various different things today. Okay, so we're going to discuss about C Sharp classes. We are going to discuss today about the class members, constructors, access modifiers, and a few other things in this today's day number 11 session to conclude the whole basic C Sharp essential course within 10 days. So I hope you have found it absolutely useful up till this point. Again, the whole playlist link is in the description. Do check it out and follow along day by day so you can learn this course if you are interested in learning C Sharp. Okay, as always, a quick disclaimer: this is still not being officially sponsored by W3Schools, so this is just a my own interest of making this course using W3Schools website. So I'm just using it as a reference, so you guys already have some point to read rather than just going through slides and another thing. So I love this website. I'm using it as a reference material. It's not an official or sponsored by them. Okay, so I hope you understand that, and I don't get any copyright for that. Finally, don't forget to subscribe, and I will be posting more sessions, and hopefully next session we will be talking more about Python. So if you are interested in becoming a programmer, learning more about it, do subscribe, like a video. Let me know in your comments what you liked about this course, what other courses or topics you want to learn, any confusion, anything. Don't hesitate to post a comment. Your comments, your likes, subscription helps us a lot, motivates a lot. Okay, and it encourages us to make more videos regularly. So I hope you do that. Okay, so let's begin. My name is Dr. Shanbaddi. Okay, guys. So now let's talk about C plus Sharp's OOP. Okay, OOP stands for Object Oriented Programming. By this, we mean that we have a specific behavior of our class and object structure that we need to understand. OOP is basically a conceptual framework. Okay, if you understand that, it means that it tries to create a framework by which a language is working. Basically, a procedural programming is about writing procedures or methods that perform operations on the data, while OOP or object-oriented programming is about creating objects that contain both data and methods. For example, language like C. C was considered as a standard programming language. It's not an object-oriented language. By programming means that it did have methods, but that's it. So in order to, or whatever operations and functions we do, we had to create methods, call methods, create methods and call methods. That's it. When we talk about object-oriented language, it contains something called method and data. Okay, and then we create an object that can use this methods and data. Then these objects can be multiple, so you can create multiple different objects of the same class. Each object will have an independent copy of their data and methods, hence allowing us to expand the coding to a whole new level with multi-reusability and multi-structuring and having inheritance and polymorphism and abstraction within our system that previously could not be achieved using simple programming. Okay, so that's why OOP is now something very important to understand and how it is being implemented. Obviously, from C++ to Java to C Sharp to Python to PHP, almost every other language now works fundamentally on OOP concepts as well. And they try to work because it is such a powerful way of doing programming. Object-oriented programming has several advantages over procedural programming. OOP is faster and easier to execute. Okay, so internally it's much faster to code. The code is always a short and it's faster and much easier to work with these things. OOP provide a clear structure of the program. Debatable, but yeah, they do have a much understandably clear program structure, which is more easy to follow and more easy to work with. OOP helps us to keep C# code dry, don't repeat yourself, and make the code easier. Dry represents, again, we call it dry, but it's not the literal word dry. It's like a figurative, and it means don't repeat yourself. Means that once you write a code, the reusability concept comes into play. We talked about this in methods as well. Similarly, this makes the whole class very reusable. Okay, so that's what the word dry comes in. And makes code easier to maintain. Yes. Okay, so you can very easily update, maintain. You don't have to change the entire code. You just add new methods to work on previous methods, overload previous methods and update them, and many things you can do without actually changing the previous code. You know, that's what it becomes. So you can do inherit the previous code and modify it and create a newer version of the code very easily. which within a standard programming language was previously very difficult to do. That's why the systems now, you see these upgraded systems happening every other day. It's because the code is so upgradable very easily. Okay. OOP makes it possible to create full reusable applications with less code and a shorter development time. Self-explanatory. So don't repeat yourself. Dry principle is about reducing the repetition of a code. You should extract out the codes that are common for the application and place them in a single place and reuse them instead of repeating it. Okay. So that's what basically the whole principle of dry yourself means. Now, whenever we talk about OOP, there are fundamentally two things that you need to understand: classes and objects. Every OOP concept, no matter which language you go into, has the same fundamental principle, and it goes across the board. Okay, so it's not like that if you understand C++, OOPs, if you go to Java, it's something different. Or if you know OOP in Java or the OOP concepts from Java, if you come to C#, it's the same. So no matter which language you go into, even you go into Python or PHP, or OOP concepts are the fundamental concepts are exactly same. The syntax wise, the working wise, there might be some difference, but the fundamentals, the basics, structuring, and the concepts are exactly same. Okay, so that's why we talk generally about this. So every OOP has something called classes and objects. So you need to understand the difference between and the usability of these two things. What is the class? What is an object? How they differ? And then how do we use? These two things becomes major thing to understand whenever we're talking about classes and objects. Having classes and objects make OOP, right? So the foundation of OOP actually stands on these two pillars: classes and objects. If you take either one of them, you cannot create OOP, and all other concepts of OOP basically are useless and are not applicable as long as there is no class and objects. So that's why we said we're understanding how classes are working, how objects are working, how we use classes and objects with each other and generate our system wide outputs. That's the key thing that we work with. So classes and objects are two main aspects of object oriented. Look at the following illustrations to see the difference between classes and objects. So now here's a very cool, very well, not cool, but very easy to follow understanding of what classes and objects are. And if you understand this, well, it makes things a lot easy for us. So for example, a class is generally considered as a prototype that contains the definition of everything that is supposed to happen for that particular class. So for example, we have a class fruit. So this fruit now is considered as a prototype. It contains definition of what a fruit needs to be, how a fruit is supposed to behave, what a fruit is supposed to taste like, what features and aspects, and what makes a fruit a fruit. How do we identify that this is a fruit or this is a vegetable or this is meat, for example, right? So this is what a class basically represents. A class contains data, it contains methods about defining a particular aspect, which is in this case fruit, or another example, this is a car. So car is also a class, fruit is also a class. For example, we can have animal as a class and human as a class. So how do we differentiate what's in the animal, what's in a human? Then we say if it's animal, what type of animal it is, so there are various different categories. So we have another, we can divide in another categories. Amphibians can be different, insects can be different animals, birds can have a different animal category, fishes can, water based animals can be different. So when we define a class, we define certain properties, methods that are associated with that class. Okay, so those properties, those methods, those data belong to a class, and all the data is basically within that class. So if I have a fruit, all information about the fruit will be inside my class. That's why we call it a prototype. If I have a car, all the information about a car, like they need to have four wheels, they need to have windscreens, they need to have doors, the seats, the players, the engines, every mechanics that goes inside a car, all that information is actually inside the car class. Understand? Now, if I jump to object, object now means that it is a single entity that represents a class. It's an entity, it's an instance of a class. Meaning that when I create an object of a class fruit, now this fruit possesses all the properties of this class. When I create an object of this banana of a class fruit, meaning that now this banana is an instance of a fruit class, or this banana is an object instance of this class containing all the methods, all the data, all the properties of a fruit now will be used inside banana. Similarly, mango, for example, again another object, meaning that now mango is another object that contains all the data, all the methods, all the attributes of a fruit class with it. If I take an example of car, so we have a car, as I said, car needs to have four wheels, it needs to have a windscreen, it needs to have a particular engine, it needs to have a battery, it needs to have an axle, and all the properties that we fundamentally say a class needs to have, we define it inside this class. So when I create an object of this class, means now Volvo is an object of this class, or as I call it, instance of a class, or as they call it, it represents this class. Okay, or we some in some books we use the word entity. Okay, so Volvo is now entity of a class, meaning that now because the Volvo is an instance of this class, this Volvo object will have access to all the data of this class. That includes the tires, the windscreen, the engine, the axle, the body, everything is now accessible and readable by Volvo. Then I create another object called Audi. This again is an instance of the same class, but now it contains all the methods and access and data of this class. Same goes for Toyota, right? So now we have three objects. We have three objects here. So these objects are basically way of using the data. A class is only representing the data. Object is way of using that data. That's why we call this as a prototype. We call this as an entity or an instance of a class. Okay. So as a prototype, it represents, it contains the data. It holds the information. It doesn't use it. To use that data, you need to create an object of a class. That's another point that we use and we need to understand the difference between class and object. So we create a class to declare, to define data, methods in form of methods and variables. Okay, so it will have methods and it will have data variables that will contain information about this class. So it will only contain data. To use this data, you need to create an object. So this object, once we create it, is an instance of this class. It will have access to all the methods of this class. And then using this object, we were able to perform operations that can use this data. Okay. Then when you create a second object, basically now it means that the object A is nowhere related to object B, even though they belong to the same instance classes. But they cannot share the data, they cannot access the data of each other, they cannot process each other's data, they cannot even know about each other. They are two independent entities. Again, whenever we have a class, it's a prototype, it's a single model. You can create as many objects of that class as you want. However, each object is completely independent of another object. It has no access, no information for that. That's why, for example, if I have a car, if I create a Volvo, Audi, Toyota, these are three independent objects. They all have same properties because they are all instances of the same class, but they are not correlated to each other. They are not corresponding with each other. They are not able to share, transfer, view, process each other's data directly, at least. Okay, because each of this data is independently shared with them. Hence, car independently shares data with the Volvo, car independently shares data with Audi, car independently shares with others. So this is how we basically try to understand this, the relation between a class and object. Class defines the data, objects use that data. Each class contains data in form of variables, parameters, and methods. When we create an object, it becomes an instance of that class having access to those methods and variables. There can be multiple objects of the same class. Each object is independent of each other, means they cannot interact with each other. They can only use the data of their parent class, their parent data or the prototype data. Okay. So a class is a template for an object and an object is an instance of a class. When individual objects are created, they inherit all the variables and methods of the class. Right? Understand? Perfect. So this becomes the basics of object-oriented language. Classes and objects. Now let's go and talk a little bit more about how classes are created in C#, how objects are created in C#, and how we use them. Okay, let's begin. So now we have classes and objects. In previous section, we learned about the basic concepts of object-oriented language. Everything in C# is associated with a class and object, along with its attributes and methods. So for example, in real life, a car is an object. The car has attributes such as weight, color, and methods such as drive and brake. Okay, so a class like object constructor or a blueprint for creating an object. So class is considered as an object constructor, means it can be considered as a constructor that builds an object. It's like the main prototype design using which objects are constructed, or it can be considered as a blueprint. It is the metadata, whatever you like to call it. But class is there primarily defining the data, and when we create an object of it, we are able to use that data. So it becomes, an inspiration kind of a thing, a holy relation. A class without an object is useless. An object without a class cannot be created. So as I said, this is it's like a very close relation that needs to be established. So when we create a class in C Sharp, you use the word class, and we have been doing this continuously. So I hope you already understand this, that every time you need to create a class, we create a class, provided it a name, recommendedly with a capital letter, but that's not mandatory. Make sure the name is a single word, does not contain space. If you are using two words, use underscore, not the minus sign or any other special characters. Second, the class name cannot be same as the variable name. It has to be different. So a variable is declared directly inside a class. It is often referred to as a field or attribute. It is referring to this thing here, a string, color red. So now this thing is something we have not done yet. In previous examples, always we created variables inside a method, more commonly main method. Here we are creating a variable directly inside the class body, outside of any method. This is known as a class variable. Okay, often referred to as a field or an attribute. Means now this is a data that is belonging to a particular car, such as, hey, this car needs to be red color, or any other color for that matter we can choose. It is not required, but it is a good practice to start with an upper letter case naming your classes. We already talked about this, and then a common C# file and the class matches it. So, and when you save this file, you save your file with the same name as your class name. Now we have been using online editors, so we are not worried that much about saving your application, but do know that every application for this online has the same namespace. Okay, it's just how the online editors are working. If you are using VS Code, so make sure you save your file same as your class name. So your file name is going to be same as your class name recommended, and then make sure you use a .cs extension. Okay, so we use .cs extension to save the file, and we use the same name as your class name. I hope that's just make a little bit more sense. Okay, now how do we create an object? So object is created from a class. Obviously, we talked about this. We have already created the class name car, and we have previous examples. We've created many cars. So now let's see how we create an object. So to create an object of a car is specify the class name. You need to specify the name followed by the object name, and then use the new keyword. So for example, we say car variable name. That's it. So this is what basically does. Just like any other variable we have created so far, integer, character, boolean, float or double, the process is same. But because integer, again, as I said, was a predefined data type, so that's why we use integer here. Character, byte, float, short, long, double, all these data types are predefined. They've been built in the system. So we use that type here. But because now we are creating an object of my own class, right? This is something my custom. So I'm going to use my custom name here. And then I'm going to give a variable name object. Okay, so this name again has to be the same name as your class name. This class or any other class, you can create an object for that matter. Because this C is capital, I have to make sure that I follow the same caps lock capital letter rule. So C goes here. Variable name, again following the same standard rules, is equals to. Now we use two other things as well. This time we have used something called new. We have not talked about this previously. Okay, so the new is basically a keyword. It's a reserved word used by C# alone. So technically you cannot use the new as a variable name. You should not use new as your own custom method name, or you cannot use new as a car name as well. So we need to be little bit careful with respect to that. Okay, what new signifies is that you're creating a new object. This new will let the system know that I'm creating an object. So this new is actually the key part here that tells our system that, hey boss, I'm creating a new object. Okay, so this new is quite important in this matter. Then we use something called car with round brackets. Now why does this start here? This is actually referring to a constructor. Okay, like I said, an object is a representation of a class. So when we create an object, we are referring to all the methods of that class. So within that, we have something called a constructor, which is responsible for building this object. Consider that, right? So this is a constructor. It's not a method because it has the same signature. So we always confuse that this is a method. Be very, very careful of that. This is known as a constructor because it has the same name as the class name. Here you cannot declare a method with the same name as a class name. Okay, I will define the difference between constructors and methods in the next section. So bear with me a little bit and we're going to talk more about this in constructors. But this is actually a constructor. So it's calling our class's own constructor and telling it that, hey, I want to create a new object and save that object information inside this variable, which will become of type car, right? So this is how we basically try to read it. That call a constructor. It's just like a builder who's going to create a new object of the and assign it to this my object variable, which will be of type car. Okay, so now this is an object. We do not call this as a variable. Okay, we do not say this is a variable. We refer to this as an object because we differentiate variable as integer x is equals to 10. Now we say this is a variable. Why? Because it holds one single direct value. So that's why it's known as a variable. We call this as an object, even though they follow same structure, but we call this as an object because it does not contain a single value. In fact, it contains all the data and methods that we will declare in this class. Okay, so currently it has this data, so it will have access to this data. Then any other data you create inside this class, any other methods you create in this class, this will have access to all of that information. Okay, because it becomes instance of that class, it is representing that class, is an entity of that class. So that's why, because it contains a huge amount of data, it's not a variable. A variable, whenever we use this word, it's always meaning an integer data type or a standard data type or primitive data type having a variable containing a single value at moment. Object meaning it's a variable of a class containing or accessing all the methods and functions and attributes of that class. Understand? Hopefully you do that. So how do we know this constructor? We have not created it. By default, whenever we have a car class, there is a default constructor injected into this code by the C# compiler. And this has been done by the good people of Microsoft and .NET. So we don't need to worry about that. Obviously, we will talk about the constructors and creating our own constructors and customizing this later on. But for now, assume that there is a constructor that is responsible for creating an object of new object and then assigning it to this variable here. Obviously, constructor has exactly a different purpose as well, but it's easier to understand this way. Okay, so as I said, we will talk about constructor a little bit more later on, so don't worry about that. So now note that we use the dot syntax to access the variables. So now what we are doing here is we are using my object. I would say, hey, there's a my object here. Dot is a connection operator, connector that connects an object with the data of that class. So my object is my object. Dot color is actually this variable here, which belongs to this class. It is outside of any method. So I am inside my public static void main method. Inside this method, I am accessing my class's data. How do I doing this? By using this object, using the connection operator, and then we are referring to the variable name that has been done. So it is printing the value inside this color string variable using my object. Same mechanism we have already used with the console.write_ln. However, we did not create an object of console class because this method has been declared as static. So we are directly using the class name and calling it here. Okay. Okay. So I hope you understand these basic things, and we want to talk a little bit more about multiple objects. And so we're going to now talk more about multiple objects. I'm going to explain how, well, basically the idea is very simple. You can create multiple objects. And then when you do create multiple objects, each object has its own representations. So how do we create multiple objects? Well, it's quite simple. Just like any other variable, you can declare multiple objects as well. So in this case, we have again class car. So we create the car as a data type, defining it that this is going to be my class. We give it a variable name, which is going to be, for example, my object1 is equals to, again, we use the same new keyword, letting it know that we're creating a new object. And then we call the constructor car bracket star bracket close. So this becomes object1. Similarly, to create the second object, we use the same signature, just make sure you change the variable name, because two objects cannot have a same name, similar to two variables cannot have a same name. So now we have two objects, as simple as that. Then when we use color and color, it's going to object1 is going to go and read the color value and print the color value. And then object2 again will have access to the same color variable. So this is what we mean, that each object will have its entity, its instance of all the methods from the same class. So both objects are able to access the color method. However, do note that both objects work completely independently of each other. So if you use object1.color to change the value here from object1, it will not affect the object2 color. And if you change the value to object2 color, it will not affect object1 either. So they are completely behaving independently. However, they are referring to their own parent prototype class methods. So you can use multiple objects of a class and access it in another class. This is often used for a better organization of class. So it's not only that you can use the object within the same class. So in this case, car is there. Inside the car, we have a static void main method. Inside the void main method, we create car and car. This is creating objects within the same class. However, you can access and create objects in another class as well. So for example, now we have class car. Okay, it contains public static void, doesn't contain public static void main. It only has a string variable called color red. And then we create another class, for example, called program. Now we say public static void main, create an object of class car, obj is equal to new car. Again, the same process, nothing changed. So what now this is going to do is that we have a file, or we have a class called car. It's a separate file, it's a separate class. It's saved as program2.cs. Then we have another file called program.cs. This again is separate. So we have two different files. The only thing to ensure that you save them in the same folder location. So they need to be in the same folder to be able to access. Then we say car.object1 and use the car object. So this will create object of this class. So now we have two classes, each working independently. So in this case, we create a car object in program.cs. And if I go into program2.cs, we have a class called car. So there are two different files. So I'm able to access and create object of car in one class, whereas the object's definition or the prototype is actually saved in another class. So that is also permissible. That is why we are able to use console as well. Console is a class that has been defined in the system and is built somewhere else in this library, but we are able to use it here. Same goes for math. Okay, so when we use math dot functions, we use math that has been defined by the system, and we are able to use it in our own custom class. So you can create, access other objects and other methods from one class to another. But there is certain restrictions that you can apply, which is called access modifiers. Talk about this later on. Okay, so did you notice that the public keyword? Now here's the key thing, as I said, the access modifier. So this public keyword here is actually ensuring that you can use this method or this data type or data type, because this goes for method as well as data type. You using it public, ensuring that you can use this method outside of this class in another class. So there is way of restricting certain code, that whether its visibility is available or not. So in this case, I am able to use this color property in a different class by using the object. So this is called a public accessibility. I can restrict that as well. So this public keyword is what we call access modifier, which specifies that the color variable or field of car is accessible for other classes as well, such as in this case program. So you will learn more about them in access modifiers. Okay, so this is how generally you can create multiple classes, multiple objects, as well as multiple classes. Okay, now let's move on to talking about class members. Class members means that data that can be member of a class, or when we say each class contains methods and fields or the data, it is a prototype. So what type of data can be put inside a class? Technically, we say there is only two types of data. One is known as data types, string color, integer max speed, belonging to a class body, not inside a method, and then we declare our own custom methods. So class technically contains only two type of data. One is called methods, second is called data type. That's it. You cannot write console.write line directly inside the my class body. This is a statement that executes and performs certain tasks. It has to be inside a method. So if you write console.write line directly inside the math class, it will create error because hey, this is a statement that needs to be executed. A statement cannot go inside the class. It only needs either data type declaration or a method declaration. That's it. You cannot even call a method directly in a class. To call a method, you again need to make sure it is called inside another method. That is why we always use public static void main. So every program we have done up till this point uses void main, which is a method known as a default method, a mandatory method. At least one method has to exist in your classes. You can have multiple classes in your program. So if you're building in complex apps, you end up creating even hundreds of custom classes. But amongst this, one has to have this static method. So in this case, there is no public static main method, because this only is used to define the data. So class public variable has been created, only defining the data. To use it, we need to call this object. Again, this is a statement. It has to be done inside a method. Similarly, this again prints a line. This is a statement. It has to be inside a method. You cannot use either of these either of these statements outside of the main method directly inside the class. So this is what we basically mean, that the class members technically are only two: data types and method names. That's it. So you declare and initialize a variable, and then you create a method or declare a method. Calling a method inside a class is also not allowed. Okay. Fields. In previous chapter, you learned that variables inside a class are called fields, and that you can access them by creating an object of a class and by using the dot. So the following example will create an object of car class with the name myObject, and then it will try to print the value of field color and max speed. So here's how we do this. Again, string color red. So we declare one variable inside the class. Integer max speed 200. Again, another variable inside the class. Then we declare a method. So it has to be main method. Inside this, we create an object. Again, this object is a statement, has to be done inside a method. You cannot do this directly. Oh, I think you can do this, sorry. You can create an object here as well, because this is again a variable declaration type. So this object creation can go inside here as well. Anyway, so at this point, we created a method here. We created an object here, and then we use console.write line myObject.color. So myObject.color will access this variable and print its value. MyObject, again, this will use this thing here. So you can use the fields, you can use the data types, data variables, and inside the class and access it. You can create an object inside a class variable and access it. Now, this is known as a class variable. By class variable means that the visibility of this variables will be across the entire methods. So if this class contains 10 methods, these variables will be accessible by all 10 methods, exactly like this. So all 10 variables will be able to use it. All 10 methods will be able to use this variable. I'm fumbling today. Okay. So this is basically what we need to understand, that we have data. This can be used by object and by simply using the object name dot color values. Okay. So this object has access to my class data. You can also leave the fields blank and modify them and when creating the object. So we can say that we have string color, string max. So we just declare the variable, we don't have initialized it. We create static void main, we create car object, and we give it a value, and then we can use this value. Okay, so if I come back here, same thing. So string color is max speed. We create an object, but because they don't contain default values, I say my object dot color. So I am able to change the value of here. Now note what happens if I just be a lazy guy and copy the entire code, come back here, paste it, and this time let me create object 2, and I change it to, for example, green, and then I change the speed to 100. And this time I again use the same thing. Okay. Now what I'm doing is I created an object, new car. I set its color and speed to red and 200. I printed its values. My object dot car or dot color, my object dot speed. So using the object, you are able to change the parameter, and you are also able to change, print or use the parameter. So both parameters, both variables have been changed, and then I print this value. Then I created another object, my object to new car. Again, same syntax. We say, okay, my object to and my object to. So using this my object to, I change the color to green, and I change the max speed to 100. Now I use console.royalty, but I'm still printing the old object. Oh, I want to see that if I change the color using object 2, will it affect this object 1 or not? So if you hit run, you see it's printing red 200, red 200. Even though we have already changed this color to green and 100, but I'm still getting red and 200, red and 200 because I'm still printing object here, right? Why this color is not reflected with here? Just like I mentioned few moments ago, every object has an independent copy of its class data. So every object is behaving independently. Each object is not concerned with other object of the same class. So when I have object 1, I change its value to red, and I have object number 2, I change its value to green. But this green will not affect this, and this red will not affect this, because they two are independent copies of this string variable. That's the key thing. That's what object oriented means, and this is what object principle allows us to do. So that each object has a different representation and an independent representation of its class object. So now you can assume that if I have a student class and I say student name, student roll number, then I can create 20 objects of the same class. So there are 20 students in the class. Each student object will be independent of each other. So once I have a student 1 can be John, student 2 can be Ali, student 3 can be Ibrahim, student 4 can be any other name, for example. Each object will be independent using the same data of a class as a prototype, same method, same functions, but they all will have independent copies of their class. So once you change data from object 2, it will not affect object 1. And if you change data from object 1, it will not affect object 2 because they are independent. And regardless of how many objects you create, each object will have its own independent copies. So now if you come here and if you try to print object 2, which we just changed, and we run the code, you will see that now it will print green and 100 because now we are printing object 2. So object 2 has its own values. You can again come back here and you can see control C, you come here control V, and I can say for example red 2, and let's just make it 250, and then I again use object number 2 to print it, and I can create as many objects as I want, no problem. Each object will still be independent of each other. So now we have green, green, green. Object 2 is still green. Okay, object 2 max speed is still green, even though we have changed it here, but we have changed it for object 1, not object 2. So now if you print object 1 values, control C and control V, hit the run, you will notice that object 1 will now be red 2 and 250. At this point it should be red and 200 because at this point the value is red and 200. Okay, so first we can in fact say this one, right? Object 1 red and 200. So initially it's red and 200, then we changed object 2 to green and 100, so green and 100 is there. Then again we use object 1 and change its value to red 200, but we are still printing object 2, so object 2 still is green and 100. It's not changed at all. Okay, so if you want you can put the constant here, for example brackets, and I can say object dash 1 and hit plus, object dash 1 color, color, and then let's just be a little bit lazy, instead of typing it again and again, control C, let me hit V, and then I can say instead of color SPEED, speed. Okay, and then this can be for example control V, make it object 2, control V, make it object 2, and then we come back here, control V, make it object 1, and then again just copy this whole thing, control C, and let's just be lazy, so make it object 2, control V, make it 2, control V, and hit run again. So we get a nice representation of what's happening. So object 1 color red, red, object 2 color green, green. So if you also need new line, you can do \n. Remember we talked about this. This is wonderful thing. \n, and then if you come here, \n. So using \n, it will add a new line to it. So without using right line again and again, I can add a new line to make my output more readable and understandable. So object 1 is red 20, object 2 is green, 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 and object 1 now becomes red 2 and 250. So object 1 is independent of object 2, object 2 is independent of object 1, and you can create as many objects as you like. Okay, and then you have a data methods here. This is especially useful when creating multiple objects of one class. So if you have multiple objects of the same class, this becomes useful because each object is independent of each other. In this case, we have string model, string color, string year, integer year, static void main. I say car Ford, then I say car Opel, two different cars, Ford dot model Mustang, red and 196, and then Opel has a model Astra, white and 205. So see this, both objects are independent of each other, both objects have their own values, and when you print this data, both objects will print their own relevant data, just like we did right now. Okay, so I hope this makes sense and things more easy to understand. Object methods. Okay, so now moving on further, we talk more about methods. Previously we've been talked about class members, so this becomes a class members. Okay, class variables, okay, that we are accessing, or fields as we call them. So this becomes a fields that we are using it. Now it's going to say, hey, let's just talk more about methods. So you learned about C# methods already. Methods normally belong to a class, and they define how object of a class behaves. So this is how we define in terms of object-oriented definition. Okay, in methods we define the definition of methods as a pure single entity method. But when we look at in form of objects and class and within the boundaries of OOP, we say that the methods normally belong to a class. So every method must be inside a class, and class can only contain methods and the data types or the fields, and they define how object behaves. So they will define what operations an object can perform. What are the things that we want to do with an object? So just like the fields, just like the variables that we create, you can access method with the dot syntax. However, note that the method must be public, and remember that we must use the name of the method following by the parentheses. So in this case, again, we have a class car, string color and speed, two fields have been created. Then we declare public void full throttle. So do note we are using public keyword here. Public keyword here means that this is an access modifier. It's like granting it an access permission that yes, objects of this car class, even within this or outside this, can use this method without any hassle. We have given them the rights that this method can be accessed outside the class or within the class. There is other access modifiers such as private, protected as well. Okay. So we say public, you can use it publicly. Void, again, we have talked about this, return type, we don't need it. So I declare a method with around parentheses. It just prints some statement here. So when I want to access this method, I say car, my object, create a new object. We say my object, this one, dot full throttle. So now we are referring to this method here. Again, exactly same as console.writeln, math.functions, or any multiple other various examples we have done. So this here we are actually referring directly a class name because this has been created as a static. However, in this case, we have created an object dot full throttle. So full throttle is the method name that's been declared inside the car class, and we are accessing it here. Simple. So why did we declare it as public, not as a static like the examples we have done in previous chapter? The reason is simple. Static method can be accessed without creating of an object. So we talked about this. I'm declaring the methods as static, so we don't need to create an object. When we declare a method as a static, it means that now this method does not need an object. You can directly use a class name dot this method name. And this is what's happening with this method, console.writeln. So writeLine or simply write method are declared as statics. That is why we are able to use the class name dot the function name or the method name. Okay, static has that superpower. In other words, it just makes your method super accessible. So you can just say class name dot method and you can use it. Otherwise, there is no other way of using this method. So for currently, because these are not static, the fields and the method, I cannot use them except by creating an object. There's no other way. To use these two things together, we need to create an object and use the object name dot and the method or the field name. That's the only way of doing it. But if we define it as a static, now we give them a superpower. Now we don't need the object. We can directly use the class name and call this guy and it will execute. Similar to the programs that we did in method as well. Don't worry, we will be doing some more tasks regarding methods and classes and objects later on. So I'm just trying to cover through basics, and then I will go and do around 7 to 8 different real world examples where we create multiple methods, create objects, use methods, change values, and do basic operations so we understand how things are working. Okay, so that will hopefully easily simplify various different things and create more understanding. But again, the examples are here. You can follow along and you can use this. Using multiple classes. Now again, this is quite important to understand. Remember from the last chapter, we use multiple classes for better organization. One for fields and methods, another for execution. This is recommended approach, as I said. So in this case, now we have a class car. So we declared string variable, we declare color variable, we make it year. But because now this needs to be accessed by an object probably created in another class, in such which will be a separate file, we make sure we make them public. Okay, so we make sure then we make them public. Then we create a new file. We write a brand new code. We create a new class name. We have a static method inside it. Inside this method, now I create a car Ford new car. So it will create an object of this car class in a separate file. Ford, again the variable name, dot model, color, year. We give it 3 different properties. This object will have these values. Then we create another object, again of this same class, having different properties, and we can use this object and its parameters in a similar manner. So if you check out this code, basically now you will have 2 different files. One file here, second file here. One is called program.cs, second is called program2.cs. Program2.cs only contains class. Okay, so this is typically how we say a class contains data and methods, or fields and methods. That's it. Then this becomes my prototype. To access this prototype, we need to create an object so that we can use these methods and variables. We can create that object within the same class, or we can create in a completely new file having a new class name. Just ensuring the namespace is same. That's one thing. This namespace ensures that both the class belong to the same namespace structure, namespace package, like a namespace folder. Okay, so by specifying namespace same will ensure that this program runs smoothly and there's no error with it, and they both belong to a same project folder, in other words, or library, in other words. And then we just simply create a class, simple as that. Okay, so now the idea becomes, the more complex programs we write, we try to have multiple class structure, so which defines the prototypes, which defines the basic data. Then whenever we need to use that class, we create objects of that class, set values for that object, and then execute it. Understand? Perfecto mundo. Okay, so public keyword is called an access modifier, which specifies that the fields of car are accessible for other classes as well, such as in this case the program class. So you will learn more about these access modifiers later on or some future. Okay. Finally, let's talk about constructors. Now, what do we mean by constructors? We discussed briefly in the last section, last section. Constructors is a special method that is used to initialize the object. Okay, just like saying it constructs your object. Technically, we use the word initialize your object. You do note that when we talked about variables, we said that this is called declaration and initialization. This is declaration and initialization, right? I have used these words. So means we are initializing a variable with a value. Understand? So in this case, this is called variable declaration only. We have talked about this the phenomena previously as well, meaning that I have variable that has been declared here, but it has been initialized here. It has been initialized here. It has been assigned a new value here. Okay. So when we go inside our constructors, constructors are used to initialize your objects. Note there is no value given to the object. So what should be the value of this? It does not contain a value because it does not contain a single value. It contains the data of a class. It represents data of a class, which is again multiple variables having multiple values and methods, multiple methods. So what should be the initialization parameter for this object? So that is why we use something called a constructor, which is used internally to initialize your object. So now through this constructor, we construct the object, initializing it with some values, if you put it way. The advantage of constructor is that it is called when an object of a class is created. Only then the constructor is only executed once. It's not written here for some reason, and it's only executed when the object of this class is created. So at this line, the constructor is called only when this new object has been constructed and executed once in its lifetime. For every object, the constructor is executed. Previously, we have not created the constructor because internally a default constructor is injected within our code by the system, right? So that's why we don't worry about the default constructor or worry about constructor at all when we start learning. Because again, the good people of this .NET and developers knew that as soon as the people working, they don't want to learn about constructors right away. They just want to create objects. So to simplify, there is internally a default constructor. Second, not every single time you would require to work on the constructor yourself. So that is why internally there's a default constructor already present in our system. However, you can override it and create your own constructor, just like now. We're going to show you. So it says, we have a class car, we create a variable called model, then we declare something called public and car, parentheses. This is the syntax of a constructor. Again, the code can be anything. The internal block is something block, again, we know defines the block of code containing multiple statements that are part of the main function or method. The main syntax is here. We set it to public because the variable or the object can be created anywhere in the same class or somewhere else. So we have to ensure that this is accessible. Second, there is no return type because by default it initializes an object, and so it will always return an object. So you cannot return something else. It always will return an object and assign it to this object variable. So that is why the constructor has no return type. Second reason is that's one key point that differentiates a constructor from a method. Okay, a method has a return type, a constructor has a no return type. That is how we identify. Otherwise, the syntax wise, it seems quite same. The third key feature is the constructor name has to be same as of a class name. Same letters, same alphabet. If you change it, it starts to complain. Well, it won't complain, it will assume that it's a method. Okay, so if I come back here, let's view this code and let me just kill some of the previous windows before my system crashes. So many windows already open. Okay, I think I will leave the class example away. So now we have class, we have a public string model, which is a field, and we created a constructor. So if you use or change it to car2, legally allowed, problem is it will generate error that now it thinks it's not a constructor, it's a method name. So in C# will assume that, hey, you're creating a method, man. If this is a method, it needs a return type. So that will be the error. And if you give it a return type, now perfect, no problem. Because now it's not a constructor, it's a method. For a constructor, it has to have a same name as your class name. If name is different, it's no longer a constructor, it's a method. But if you forsakenly do use the same name and you forget to remove void, again, that will bring a problem because that's why it will get confused. So how we identify a method from a constructor? 2 points. First point, there's no return type. A method has a return type. Second, the constructor name is always same as a class name. A method name is different from the class name. Usually that's a standard practice. Okay. So now what we have done is we have created the constructor. Public class car without any arguments. We give it some values. So now we come here, car, Ford, new car, and notice what will happen that when you execute this code, it prints Mustang. However, we are printing model here, and because the model value has been set here in the constructor. So constructor once initialize the objects, the code you use is exactly same as a method. Okay. So whatever code you can write inside a method, you can write inside a constructor as well. No problem with that. You can declare variables, you can print statements, you can do everything within it. So I can have this statement right here, control C. I can even say print, and I can say, for example, let me just use this value, and I can say constructor CALLED called. And if I run the code again, it says constructor called. Okay, and then it's printing here. Why the constructor call statement is first? Because we created an object. So main method is with the execution point. This methods get executed, it creates an object. When object is created, the constructor is called and the this constructor is called. Hence it will assign the value model to this variable, model variable to the Mustang. Then it's going to print this statement. So this statement in form of output gets printed first. Then the control will go from this point to this point, and the for.model is used to print value inside write.ln method. Okay, so constructor becomes here. What if I don't use the constructor? Control X, perfectly legal, because now default constructor is already there. I talked about it. But if you use the constructor, now actually this is what we call constructor overriding. Okay, why overriding? Because a default or overloading, sorry, let's just use the word overloading. Why overloading? Because remember in methods we talked about method overloading. Okay, this means that the constructor having same name, different number of arguments. So this is already declared. So since the constructor is already declared default, we are creating a new second version, an overriding version. In fact, this is overriding word. Okay, sorry about that again. Overriding in my understanding. Okay, because overloading is different. Sorry, overriding means that the public default constructor is already there, and we are actually replacing it and using our own method. Okay, so we are overriding the previous default constructor. If you don't use it, the default constructor is used. However, when you use the car, you are overriding the previous car default with your own custom thing. So the word is actually overriding. Overloading means that we can declare and we can do method overloading, just like method overloading. I can have integer x here. This is again perfectly allowed. Or in this case, let's just use, for example, a string mod, and I can say, listen, this model value should be equal to mod here. This is perfectly okay. What now it means is constructor called with model. Okay. So what this is now meaning, or this is what it's trying to do, is that now I have an overloaded constructor. Okay, so this is constructor overloading. Just like method overloading, where having same name but different number of arguments. We talked about this in method overloading. Method having same name but different number of arguments. Same applies with the constructor as well. So a constructor can be overloaded. Okay, overloading means a constructor having same name, and constructor has to have same name because the names come from class. So this car default without any arguments, you can overload it and you can provide it an argument. So now what we're going to do is we're going to say, hey, if I create car, this is also perfectly legal. It's going to call this constructor automatically. And let's be a little bit more lazy. Copy this entire code, paste it. And this time I'm going to say, for example, this method. and let's just change this to ty, and let's be lazy, not write the full name, and I write ty. Now if I run the code, if everything is okay, it creates a constructor called with a model and Toyota is printed. Okay, so constructor called with a model is this one. So when you use constructor without without any arguments, the default constructor is called. If you provided an argument, now this overloaded constructor is called, that takes a string argument. Okay, and then there can be as many arguments as you want. So if this contains 3 arguments, you would have to use constructor that needs 3 arguments. Understand? So same overloading principle that we discussed in the method overloading is also applied in constructor overloading. So note the constructor name must match the class name. It cannot contain the return type, blah, 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 things already discussed. All classes have constructors by default. If you do not create a class constructor yourself, C# will create one for you. However, then you are not able to set initial values for the fields. Okay, so if it is created by default, you cannot initialize within the constructor the default value like we have done here. Okay, so to do this and to print that statement that hey, constructor called, object created, and so on and so forth, we actually need to override it and define our own functions. Okay, so constructor parameters, same thing. I think I already talked about this anyway. So you can give constructor parameters. So you can say public car having a string name. I already talked about this. And then when you create the constructor, you give it a value. So now it is going to use this value, pass it to this variable here inside the bracket. This value then be used here to rephrase, assign this value value. So this is another workaround way of initializing a variable while the constructor or while the object is created. And then when you print it, it prints the same value. Okay, makes sense? I hope it does. We'll try to do a few examples later on so that you understand how things are unfolding here. Okay, so you can have these parameters as you want. You can have as many parameters as you want, sorry. So you can have like a string model, color, year. So I create a constructor that has string model color, and model year. And then I initialize these variables with this variable. So now what's happening is that model name, whenever I create, I will assign here. And this model name is used here to assign value to this model, which is actually this variable here. So actually I want to assign value to this. So to assign a value to it, I have left it on the object creation. So when we create an object new, we call a constructor with 3 arguments, constructor with the 3 arguments. Do note that here you can create a constructor without any arguments as well. If you do, it will call the default constructor. Okay, that's always there. So if you don't provide any argument, the default constructor will be called. No problem with that. But to initialize the variable's value, the default constructor is not useful, so we created our own constructor. So this is what we call overriding. So we say Mustang, comma red, comma 169. So what's happening now is this value will be assigned to this string variable name here, model name, which will again inside the block, this model name will now contain this Mustang value because we just assigned this and passed it through as a reference. Okay, so then this model value will again be assigned to this model variable, and this, which is basically this string variable. So now when I use for dot model, it's going to print the model that I just created, red 169 Mustang. Okay, so it just understand the logic of how data is being passed, how data is being used, how data is being initialized. So if I copy this whole code again, I create another object, and this time instead of Mustang, I can say, for example, BMD, and then I can say, for example, blue, and then let me just say, for example, 2004, 24, hit run. It gives us error. A local variable named Ford is already defined in the scope. So basically meaning that we have created 2 variables called Ford, not allowed. So let me just change this to BMX. And then instead of all of this thing, I'm going to use BMX, and Ford I don't like, so I can say BMX. And then again, Ford I don't like, I'll say can BMX. So now I change the variable names and values. So because this variable needs to access the color, this variable needs to access year, this object again needs to use the model. So once you update it, now we have different values. So object 1 is red, 1969 Mustang. Object 2 is blue, 2024 BMX. So both independent objects, both setting, both calling the same constructor, passing it a value based on that. So when I give it BMX, as a create initial as a create new object, initialize it with this constructor having these parameters. So these parameters will be going assigned to this variable value. Okay, then this value will be assigned to this model. Okay, so what we are doing is we are passing data from one point to another, from another point to another, and assigning it to a third point. So this is called pass by value, or which means that we are passing value from one point to another. So the value BMX is being passed from this point, assigned into this model variable. Now this is the container, but this is a temporary container. Then from this temporary container, we assign it to the main container model. Hence, when we use the BMX object, we use this model parameter to fetch the updated value, and it's going to come to us. I hope it makes sense. It's not too overcomplicating things. Okay. So constructors save time. Just like, for example, sorry, this step, just like other models, constructors can be overloaded. We just explained this concept already. So I think that covers it. It says constructors save time. Without constructors, this is how we write. We write Ford model, Ford color, Ford year, but and then open model, open color. So see this, what's happening now is that we are repeating multiple lines of code for each object. This is what we did previously as well. Okay, so we created one object with a default constructor. Then to initialize its value, we gave these parameters separately. However, if you use constructors, see this how short the code is, because now we said create a Ford object car, and then inside its arguments we directly pass three values. So instead of using these three separate lines, we just use these three values, and value object has been initialized with those particular values. So it simplifies and makes things a lot easier. Okay, if you understand it. So I hope up till this point it's quite clear. For now, I will end this session as well as this whole series of C# here. Next, I will be doing a couple of examples of classes and methods and objects, and try to cover as many things as we did within a few of those examples. Okay, so do stick around. See you in next class. Okay, guys, so this concludes our day number 11 session. And in this, we talked about the C# oops, and we talked about various different things as much as we can in this, using W3Schools website as a reference. So I hope you found it interesting. This was a wonderful journey in 10 to 11 days. Try to cover as many essential topics of C# as we could. Okay, I know many things are still remaining, but it actually now depends up to you. I want to see how many of you actually want to learn extra topics, so I can make a video for that. And if nobody is like interested, it's no point making things that nobody watches, right? So I want to see how many people reach to the end of day number 11 and they're still interested in learning the next part of this course, so I can make them, and I will keep posted on that. Okay, there are a few other things that I will be making randomly about C#. Some example programs, I will be working on them, so you can follow along. I'm still working on creating the lab manual, so I will hopefully post that very soon. As soon as I complete, in the description you can find that. So do watch the whole course. Let me know in your comments what you liked about this course, what are the things you want to learn, and what other things you want to know about C# or any other technology there is. Okay, so thank you very much, those of you who have watched it, liked it, and give me wonderful comments. Those who still haven't, please don't forget to do that. My name is Dr. Shan Bhatti. This is signing off from C#. See you in next course.